Hello everyone. So let's discuss about the problem that is 3440 schedule meetings for maximum free time cycle. So in this question we have given an integer event time that denotes the duration of the event. Also two integer array that is start time and end time and each of length is n. These represent the start and end times of the n non-overlapping meetings. Means start time Start time represent the start of the meeting. Start of meeting and end time represents end of the meeting. Also, we have given the non-overlapping meetings. We have n non-overlapping means all meeting is non-overlapping. So non-overlapping that occur during the event between the time equal to 0 and time equal to event time means that all meeting can occur. All meeting can occur within the equal to 0 to equal to event time. These all within within the time. Okay. So so we can reschedule the at most one meeting by moving its start time while maintaining the same duration. Means that we can move the meeting. Let's suppose we can move 1 comma 2 to 2 comma 3 while maintaining same length. Okay. So that is question. We can move the at most once. Means that we can apply one operation to anyone, and we have to return the maximum amount of free time possible after rearranging the meeting. Okay. So also there is a condition here. The meeting cannot be rescheduled to a time out of the event, and they should remain non-overlapping. Okay. And it is valid to it is valid for relative alternativity to change after rescheduling meeting. Means we can change the ordering of the meeting after rescheduling. So let's suppose the meetings are this. Means that we can reschedule this meeting to any place like here. So that is possible in the question. And we have to find the free time, maximum amount of free time possible after rearranging the meetings. So first example, let's understand first example. Example, we can reschedule, and if we don't reschedule, then what is the maximum time? It is 1 and 1. We get maximum time is equal to 1 if we do not reschedule. If we reschedule, means that we can reschedule this meeting to here 2 comma 3 or this to 1 comma 0. Then we get the 2 time. So answer is 2. So to solve this question, how to approach to solve, we can say that we only change the meeting only at most one time. We can only modify the array only one time. Means that we can choose a meeting and reschedule to anywhere if possible. And how it's possible? We check we check if the meeting size means that the meeting size is already present another place. Like here is a meeting and the meeting size this is greater than the this one is this meeting size greater than one, so we can reschedule this meeting to here. Okay, so the time is we can get the time after rescheduling this meeting is 1 to 9, which is 8. But in this example, that is not possible. We can reschedule this this meeting to here. After that, we can get time equal to 8 to 1, that is 7. So we we want we want if there is a possible that we can reschedule this meeting to anywhere, then we get the time that is left. Let's suppose this is left. Let's suppose this is left side of the meeting and this is the right side of meeting, and that is meeting size. Okay. So there is a two case here. If first we can reschedule. If we can reschedule the meeting 7, 8 here to any place, then we get the length is left plus right plus meeting size that is equal to what is end of I minus start of I. Okay. If we can reschedule, if we cannot reschedule, if we cannot reschedule, then we can shift the meeting to its either lower side, means we can shift to here, or right side like here. Then we get the meeting sizes left plus right. What is, let's understand clear, is that if we cannot reschedule this meeting to any place, then we can shift it to right side, means here. Then we get the maximum length is this, which is left plus right, and this acquire either left side or right side. So we get the length is left plus right. So our main question is how to check if there is a meeting size present. The our main question is how to check. Uh, question is how to check how to check our meeting size. How to check any meeting size, any meeting space greater than or equal to current meeting size. Means that current is this. We have to check if they're possible the size of this. If any place the size is greater than current meeting. So if there is a possible, then we can rearrange this meeting to any place. So how to check effectively? So to checking the effectively, we use the multiset. We use multiset. How can multiset help? Because of multiset, we can first, because in multiset, insertion and a insertion and removal is around log n time. Okay, so we can solve this question using n log n time. Why? Because we have to remove this meeting in log n time and insert this meeting in log n time. So, so let's understand how can we done this question. So we have to maintain the multiset of the spaces, multiset of the spaces. Okay, we have to store the multiset of the spaces. Let's suppose this is store the six and one, and also lower and upper also possible. If the meeting size, if event time is this, then this is also possible. So we have to include this also. Zero, that is start of zero minus zero, and also maintain zero for here event time minus end of last, end of n n minus one, end of n minus one, which is last. So maintain. So after after approaching, so we can traverse through the array from starting from first meeting, and we have to first remove this meeting and this meeting, left and right. Why? Because after removing left and right, if we can get the meeting that is greater than the meeting size, means after removing, if let's suppose we have to remove the, let's suppose we have to remove this meeting. So its left is 6, its right is 1. If we can remove the left and right, it's 6 and 1. If there is a possible, that is max size store, we can get the max size using reverse begin, multiset dot reverse begin. So if that is max size stored in the multiset, if that max size is greater than the current size, then we can reschedule. Otherwise, we cannot reschedule. That's the catch. So let's understand the core part of this. Core part of this. So first, we have to insert. We have to declare the multiset ms. After we can insert all the spaces on the multiset that is occur during start time. Start to zero, that is start of zero. Also start of zero minus zero or start of zero. That's okay. After that, we have insert the last, which is event time minus end of n minus 1. And all other are spaces between the intervals. That is start of I minus end of I minus 1. Means that is start here and end of n minus 1. So that is space. Okay, present between them. So we have to insert all the spaces. So our task is we have to find left and right. What is left? Left is I equal to 0. Then left is start of 0. Means space present between current element and the left side is start of 0. Otherwise is start of I minus end of I minus 1. Similar for I equal to n minus 1. The right side is event time minus end of n minus 1. Otherwise start of I plus 1 minus current end of the I. Okay, after that we have to remove the left and right from the multiset, and, and we have to check the last storing the maximum size. That is, if the maximum size is greater than current meeting, means end of I minus start of I, then we can get the max. We can maintain the result value that can store the maximum spaces possible. We can maximize the rest equal to left plus right plus current of sides. Otherwise, we cannot get the residual meeting. Then we have to right plus left plus right. So after removing, first we have to remove the left and right. After that, we have to insert left and right because this left and right can be possible for another meeting. So we can get the answer here. And what is the complexity of the problem? We have complexity. We have to traverse through whole array, means and time. But we have to insert in the multi-set. So that take log n time. So overall time complexity is O of n log n.